Hello everybody, continuing our lesson here from growth factors and growth rates. We talked about our rabbits growing. We did the growth factor versus growth rate form worksheet, and then we skipped ahead a few worksheets to do a little practice. Now I'm going back, so this is the page in your packet right after the growth factor versus growth rates, and this is part B, and C we'll try to do. Alright, so like I said, when Sam is in 7th grade, then it gives him some a stamp worth 2,500. Sam's considered selling the stamp. If he saved it, it would increase in value. Sam saved the stamp, and its value increased. All right, there it is. Increased 6%, and originally started with 25%. So now I'm giving you the rate of increase here, right? So this is the rate of increase. Maybe we'll get that. Maybe not. Okay, there it goes. Rate of increase there. So now what do I do with this rate of increase? All right, so we'll start with making a table, sure. So we got 1 is 2,500. Okay, and it increases by 6%. So you have a choice here. You could find 6% of 2,500 and then add it there, or you can multiply 2,500 by 1.06. Alright, so where am I getting this number from, right? So my money's not going down, right? So I'm definitely going to have the $2,500 in there already. And some more money, right? So how much more money? Alright, so that $2,500 that's in there, it represents the 100% of my money that I'm starting with. Well, I'm going to have more money, okay? So let's get rid of that. And how much more money am I going to have? Well, I'm going to earn 6%, so I'm going to have another 6%. I'm going to have another 6% on top of what I started with. So I have the 100%, I add the 6%, and that gives me 106%, which is 1.06, which is also my growth factor. Right? So the rate of increase, the growth rate is 6%. Add that 6% to the 100% that you start with, hence giving you the growth factor or your B value in your equation. So now we know B is equal to 1.06, and I'm starting with 2,500 and moving forward. So I'm going to do 2,500 on my calculator times 1.06, and I get 2650. All right, and the following year I'm going to get 1.06 of that 2650 again, and I'm going to get 2809, and I'm just multiplying by 1.06 every time. 29, 77, 54, and now this is where my numbers get a little off because now I get to this decimal. Well, this is the value, and 2,500, 2650, 2809, 29, 77, 54 are all legitimate money values. Now you get to 3156 point, and if you have this on your calculator, you see 0.1924. So I'm going to stop at 19. So if I stop at 19, fine, and I multiply here at 1.06, and I multiply it by 3156.19, your answer on number 5 might be slightly different. If I carry that decimal over that I got, 3156.1924 times 1.06, alright, my answer will be a little bit more accurate, but it might start to be slightly off or slightly different than yours if you multiply by there. But we'll check both ways. So if I kept the decimals all the way, kept all my decimals, I'm going to round this one to 3345.56. 3156.19 times 1.06. And you're going to get the same number either way. So times the 1.06, whether you took the rounded number or took all the decimals after that, you'll get the 3,345.56 cents either way. And that might change as you go down in the values, as you go down in the years, but we'll stop at 5 and go from there. Alright, so make the table, check for the first 5 years, look at the pattern of growth from 1 year. Sure, it's the growth pattern. Well, yes, it's increasing by 6%, so the growth rate is 106% or 1.06, right? Write the equation, V of n, so awesome, so V of n equals, Again, I could start with the a times b to the n power, but now we know what a is. So v of n equals, my a is 2500 that I start with, times my b is 1.06 n to the n power. And now moving on. So once you're here, then the next two questions could be once you establish your equation, the next two questions I'm either going to give you the n and ask you for v of n, or I give you v of n and ask you for n. So right, I either give you the input, I give you the input and you solve for the output, or vice versa. I give you the output and you solve for the input. All right. So let's see what this next question asks. It says, how many years will it take to double? All right. Well, how many years? So I'm asking for the years. So the input is the missing piece, and I'm giving you the output. It's going to double. Well, if I start with 2500 and I double it, I get to 5000. So when will your equation equal 5000? When will 2500 times 1.06 to the n power equal 5000? All right, and this is where I would bring out my handy dandy calculator. I mean, you could keep multiplying by 1.06, but you're going to pass over the 5,000. I doubt it's going to hit it exactly. So I'm going to use my calculator for this one. I'm going to do y sub 1 equals 5,000 and y sub 2 equals 2,500 times 1.06 to the n power. And when I use my calculator, I'll use x instead of n. All right. So let's take a look at that one. 25, 1.06. All right, and then 5,000. So let me grab my calculator back here. All right, so there's my calculator. This is from the last video, so I'm just gonna get rid of this. Clear and clear. All right, and we have, so one is going to double, so one am I going to equal 5,000, and I started with 2,500 and y sub 2 times 1.06, all raised to the x power. So if you just hit graph now from this calculator, you're going to get to this basic window here, and you may or may not see anything. All right, so you're definitely not going to see the 2500 because your window's not adjusted. So again, if you need some help with adjusting windows, we'll do it here in the video, but remember there's another video on seeing that as well. All right, so the X max, I'm going to put 25 just for fun. Again, the X max, I wouldn't go too high with that. Things get your y values tend to increase very, very rapidly with exponential functions as your x moves, so you don't have to move a ton of x values for that. But the y max, you got to be a little more careful for. We know we need a minimum of 5,000, so I'm going to put 6,000 just to overestimate it a little bit and just to make sure I see the graph a little nicer. So there's my exponential function growing at 1.06. Here's my horizontal line at 5,000, and there's the intersection there at some x value that we can easily calculate with our calculator. So second calculates, press the number 5, first curve enter, second curve enter, guess enter, and it looks like 11.895. So 11.9 will win that one? Sure, why not? So when x is, or when n is about 11.9-ish, or if you just want to say about 12 years. So once he's in there for about 12 years, he can double this up. All right, so the value of the stamp, and okay, so depending if he's put in an investment, most investments won't let you come out 11.9 years. It's usually solid years or by months or something. But so either answer would be great. This is more exact. I would like to see that on your worksheets or whatever problem you're doing, because I want to see that you're able to use the calculator and find the intersection there. All right, and then there's a part C to this. We're 9 minutes in. Let's see if we can get through this one a little easier. Okay, so suppose the value of the stamp increased by 4% instead of 6%. All right, so same kind of problem. This time the growth factor is, well, I always start with 100%. I'm increasing by 4%. That gives me a total of 104% and a growth factor of 1.04. All right, so he still started with the same amount of 2,500. This time and you could work this one all the way down, multiply each one by 1.04. That's up to you. All right, and then we want the equation. So again, The variables we used were v and n, so v of n equals a times b to the n power. A is still 2500. B this time is going to be 1.04, right? Because our growth rate has now changed to 1.04 because our increase is only 4%. And let's get our equation now. So we got v of n equals my y-intercept, right? Whenever you have 0, that's your y-intercept. 2500 times 1.04 to the n power. All right, and then again, the same question says, when will it double? Okay, cool. So y sub 1 is going to be 5,000 again, and this time y sub 2 is going to be 2500 times 1.04 to the n power. All right, so I'm going to let the calculator do its work again in this one. So let me go back to my calculator app here, and I'm going to hit y equals and bring me back here. Now here's a cool feature. So if you don't have to clear all this out, right? If your cursor's on the number, then you could just easily replace that number with anything you want. So if this was 2,900 that he invested, then everything else stays. All right, so I'm going to leave that as 2,500. But I'm going to go over this 1.06 and make this 1.04. And then that will be my new growth rate there. And it's still going to be 5,000, still going to double at 5,000. If I click on my window should be exactly the same from when I left it. So my window is 6,000, my X max is still 25, so all that's good. Making this problem go a lot faster. And let's see, we graph that. So there's my two equations, right? My horizontal line at 5,000, my exponential function now with a new growth rate of 1.04. All right, some point of intersection here that my lovely TI-84 calculator is going to calculate for me. So second trace or second calculate. Number 5 for intersection. The cursor is blinking on the first curve. Thank you. The cursor is now blinking on the second curve. Now enter. Again, thank you. Guess and thank you. And now guess. And now I get a new rate of 17.67. So I'll round that to about 17. So an n is equal to about 17.67. So about 17.7 years, or if you want to say about 18 years to double. Right? Again, when you start investing into, when you have investments of these stamps or you put your money in, you probably have to wait the full year, but not always. All right, so again, give me both answers if you want to leave it, or if you just want to leave this answer, that's great too. Okay. If you were to graph the two equations in part B and C, how would the graphs compare? And what would stay the same? What would be different? All right, cool. So let's actually look at that one. So let's graph that one, and let's do this with our graphing calculator. All right, so how would I graph the two equations in part B and C? So I'm going to go back to my calculator. So I'm going to go y equals, and I'm going to change this equation here to 2,500, parentheses, 1.06 to the x power. So I'm putting back that original equation that I had. And I'm going to look at the two graphs of these. All right, so let's see what that looks like. And I'm going to hit graph. And there's 1, and there's 2. So if you notice, they're both going through the same y-intercept, right? That's not changing, right? When x is 0, so second, I'm going to show you guys another little one. So second calculate, and I'm going to put a value here, enter, and I want to know when x is 0, what is y, and it's 2,500 for both of them. That's one way to see it. If you do second table, you can see a little comparison of both these numbers. So, and when x is 0, 2,500, 2,500. When x is 1, I got 2,650 and 2,600. So the first equation was the one that was 1.06 growth factor versus a 1.04 growth factor. So y sub 1 should naturally be bigger because it's growing at a faster or a bigger rate. All right. And then if I go back to graph, so if you go down if you keep going down, you see that of course the y1 is always going to be greater than the y2. And then for comparing the graphs, right? So y1 is in blue here, so it's a nice little feature about this calculator, the CE edition, so the color edition. All right, so the 1.06, the bigger rate is in blue. So what are we seeing here? That the bigger rate is growing faster than the red line with the small rate. Now, just for fun, let's change this window, and I'm going to do a y max of, let's do a y max of 50,000. Is this thing ever going to hit 50,000? Maybe. And do an x max, I'll do 50. So we'll do 50 as the x max and 50,000 as the y max, and just take a look at what's going on here. So, and there's the two rates that you see. So over the years, the 1.06 really does grow a lot faster than the 1.04 growth rate. All right, so that's the piece here on part A and B here. Or, I'm sorry, part B and C of the growth factor versus growth rate. And then we'll take it again. We'll take it nice and slow. It's about 15 minutes in, and then we'll finish off with part D tomorrow, and then go from there. All right. See you guys soon.